So we've got two distances catered for between the cafes and the railroads and the cafes and the parks. But there are other things we can do as well. We could, for instance, if we are using the Arc toolbox and use, for instance, the densities of the spatial analysis toolbox to see if there is any sort of contextual thingies, like the number of cafes or the number of stations or the number of parks or whatever per square meters or square kilometers. I would consider the likelihood for something being there is that we've got a multitude of things. And one of the things we have for a study is we've got two things, in fact. We can either study the POIS, the POIS project, and see if the density of things in general, from any kind of perspective, it could be, as you remember from perhaps at the beginning, the ATM machines to cafes to hotels to whatnot. So generally, the clustering of the urban dense areas could contribute to an increase in cafes, which is, I guess, likely to do. And another way we do is to see if there's the increased rate of cafes per square kilometer also is something we can pick up. So what we are going to do is to do the point density. So I double click point density, and what I'm going to enter first is the cafe project. So I'm going to see if we've got any concentration of the cafes themselves. And in this case, I'm going to choose an output cell size in a raster. So we move from a point to a raster cell size, and I'm going to choose it to be 100 meters. But the area where we collect the data is going to be in the shape of a circle, is going to be on a 2 kilometer radius, and is going to be expressed as square kilometers. So the question being asked is, how many cafes do I have within the radius of 2 kilometers from any cell of 100 times 100 meters? And I should represent the values and present the values as the share per square kilometers. And doing what I did here is actually going to cater for that, but what we need to do is that we need to go to, let me see, cafe, and we need to get to a results, and I'm going to call it here, let me see, we could call it Cafe Raster. And if I click OK, we could see here in the lower right corner that it thinks. And we get something that is being illustrated. If I take these ones away, you could see the distribution. The distribution, let me see what kind of format it is. The symbology is presented in equal intervals, which means that you've got the same identical intervals between all the values that are being represented and depicted by colors. Of course, those are not statistically sound, so I would rather go for something that would be some, perhaps, Jenks. It's got nothing to do with the regression, but it's kind of handy when it comes to understanding how the distribution of things looks. So in this case, from the lower numbers, 0 of course, where we got no cafes whatsoever, up to 31 cafes, in some of the more dense central parts of the city per square kilometer, which is actually a quite large and big number. The way of getting this kind of statistics and other kinds of statistics into the data material would be to find a thing where we could pick up the values and just express them through the points. And it is something called extract values to point. And it's also under the spatial analyst tools, and you double click the extract values to point. You input the points that you want to use, and since we are collecting the data for the cafe data set, we use the cafe project use, and the raster would be the cafe raster, and we make sure that we save it, and this time it has to be a new file. So it has to be cafe, and in this case it would also be the density of cafes within a 2 kilometer radius. So I would suggest that we call it something like cafe plus raster. And if I click OK, what it will do is that it will present new buttons. And in this case, if we open attribute table, we could see that the raster values underneath have been collected up and brought to the dataset. So, in difference from the earliest version, where we had nothing beyond this main variable. We have the distance to the park, we have the distance to the stations, and we also have the density of the cafes per square kilometer. There's one thing I think we miss, because we're going to bring it to a third-party software, and this is that we need coordinates being lifted up. And even though we know that the points file know where they are located, I would like to create standalone x and y variables that we can use for the future. So I'm going to use add and long integer, because I don't want centimeters. The precision of cafes is well enough when it comes to meters. And I'm going to write x. And then I do it again, add fields, long integer, y. And there's a very good function for this. You've got the calculate geometry. You can see here that you can choose what you want to do. And you've got, since you've got points, you've got no options. If you've got areas, you can also do area of it. But I want it expressed in meters in the format of the square, which is the one I want. And if I press OK, it is going to express it for me. And I do the same for, let me see, this one, calculate geometry. And I select the Y, and again the meters, and I make sure that everything's correct. And I press OK. And there we do have it. We have the X and Y coordinate for the cafes.